So, today we've been talking about sound waves and everything, and so what we're going to do is, he's going to explain resonance. So, you have your tuning fork going at a specific frequency.
Yeah, our tuning fork is going at 426.7 hertz.
Which means it's vibrating that many
times per second.
Yeah.
And then we figured out the quantity of air that has the same resonance, so it's also vibrating at the same rate per second, so the two waves are constructively interfering so that when they're together, you get a larger amplitude, so it's louder.
That was the best explanation ever. Okay, and what we're going to do over here is I'm going to do the same thing, only I'm going to have it coming through a speaker. So, who can tell me what physically happens to the speaker when it generates sound?
It compresses and decompresses.
The what?
Air.
The air. So it has pockets of high density and low density. By doing what? How does it do that? Can you tell me, how does it make the air compress and decompress? What is it physically doing? How does it move? Up and down. Moves up and down. Okay, so I'm going to attach that right here to the end of this Rubin's tube. And so it's going to cause the air inside this tube to compress and decompress. When it hits the end over here, what do you think is going to happen to that compression? What happened when we had the water and then the thing dropped in and hit the walls? Bounce back. So it's going to bounce back. So it's going to have this like bounce, 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 bounce back and forth. And when it bounces at just the right resonance, so at the right frequency, it's going to have this standing wave. You guys remember the standing waves from last time with the slinky?
Yeah.
Where you can see it staying? Let's do it with slinky. Here we go. Taylor, you hold one end. Ah, no! Go. Okay, you hold one end. We're going to see if we can get a standing wave. It's got to stay put. Is it staying put?
Getting close.
There we go. That's a standing wave. Oh, close to it. There we go. That's a standing wave. Where it seems like it's holding still.
Yeah.
The crests and the troughs are in one spot. I have to go at the same speed and I can't. Okay, so that's a standing wave. We're going to be able to get that happening with the air inside the Rubin's tube when I light it on fire. So the air inside... Whoa, did you see the spark? Okay, that was fun. I was too busy looking at the spark on my shirt. Okay. Get the gas to go in. So it's like a whole bunch of Bunsen burners. All in a row. Is it all lit? I can't tell.
Yep.
Just
yeah,
about.
you're good.
A little bit more gas. All right. Matches. Can you get the lights? All right. So I've found that the A. Hey, look at my shirt.
Happy birthday.
Don't look at my shirt. It's glowing. Okay. We're going to talk about light waves next class, so that'll be fun. And why my shirt is glowing. But here's an A. I don't know if it really works, so we're going to try. Here we go. Top 20 guitar solos of all time. I can't do it for too long because it's going to catch on fire, like legitimately.
Okay.
Okay.
Oh.
All right, number 20. Let's do one of the better ones.
Eddie Van Halen.
Alright, number 3, guitar solo of all time. Oh no! Can you look? Okay, I'm scared it's gonna come up, so let me just turn it off now. Alright, what was the number one? Number one was?
Led Zeppelin.
Stairway to Heaven. Alright.
Called it.
So, that is sound waves.